Welcome, space enthusiasts, to humanity's next giant leaps into the cosmos, NASA's bold vision for space exploration. We've landed on the moon, but this isn't about checking boxes. It's about pushing human ingenuity and scientific understanding. For every question answered, a dozen more arise. This thirst for knowledge fuels NASA's endeavors. From the moon to Mars, we're entering a new golden age. It's about establishing a sustained human presence, building infrastructure, and conducting groundbreaking research. Are we alone? How did life begin? What is the fate of our planet? Buckle up, space cadets, for NASA's thrilling journey. Prepare to be amazed and inspired by human ambition. We're rewriting the future of humankind among the stars. Now, some of you might remember the Apollo missions, a time when humanity collectively held its breath as we took our first steps on the lunar surface. But Artemis is not about reliving past glories. It's about building upon that legacy and establishing a sustainable foothold. We're talking about a long-term commitment to lunar exploration. Artemis III will see the first woman and the next man set foot on the moon. The Artemis Base Camp will serve as a hub for future missions, a stepping stone to the stars. Imagine a space station, but not just any space station. Picture a spacecraft parked in lunar orbit, a celestial pit stop for astronauts. This is the Lunar Gateway, a vital part of NASA's Artemis program, a cosmic layover for docking, research, and mission prep. It's about expanding our deep space capabilities, a test bed for future Mars missions, and a scientific laboratory in space. The Lunar Gateway is a critical step in humanity's cosmic journey. From the dawn of humankind, we've gazed up at the night sky, our eyes drawn to a celestial neighbor, a rusty red beacon in the darkness, Mars. For centuries, it has captivated our imaginations, fueled our dreams of extraterrestrial life, and beckoned us to unravel its secrets. And now, my friends, that dream of reaching Mars is closer than ever before. We're talking about putting human boots on Martian soil, a feat once relegated to the realm of science fiction, but now firmly within the realm of possibility. NASA's ambitious plans for Mars exploration involve a multi-phased approach, a carefully orchestrated symphony of robotic scouts, technological marvels, and ultimately human explorers. It's not just about planting a flag on Mars and declaring victory, though. We're talking about searching for signs of past or present life, studying the planet's geology and climate, and understanding the potential for future human habitation. These missions will fundamentally reshape our understanding of our place in the universe. The journey to Mars is fraught with challenges, no doubt, but the rewards are immeasurable. It's about pushing the very limits of human ingenuity, inspiring generations to come, and answering one of humanity's most profound questions. Are we alone? Now, you can't just hop on a rocket and blast off to Mars on a whim. It takes meticulous planning, groundbreaking technology, and a deep understanding of the challenges involved. That's why NASA is taking a strategic, step-by-step approach to Mars exploration, building upon each mission and paving the way for human arrival. We're talking about missions like the Mars Sample Return, a collaboration between NASA and the European Space Agency, which aims to bring Martian samples back to Earth for analysis. This is huge. Imagine the scientific breakthroughs waiting to be unlocked by studying actual pieces of the red planet in our laboratories. And of course, before we send humans to Mars, we need to make sure we can get them back safely. That's where advanced technology development comes in. From developing more efficient propulsion systems to designing habitats that can sustain human life in the harsh Martian environment. These preparatory missions are crucial for mitigating risk, testing technologies, and ensuring the success of future human missions. They're like the dress rehearsals before the main performance, ensuring that when we do send humans to Mars, we're ready for whatever the red planet throws at us. The International Space Station, a shining testament to international collaboration, has been our home in space for over 2 decades. It's a marvel of engineering, a laboratory in orbit, where we've conducted groundbreaking research in fields ranging from biology to materials science. Think about it. We've learned how to grow food in space, studied the effects of microgravity on the human body, and observed our planet from a unique vantage point. But the ISS is more than just a research facility. It's a symbol of what humanity can achieve when we work together towards a common goal. However, even the most remarkable structures have a lifespan. As we look towards the future, NASA is planning for the eventual decommissioning of the ISS, aiming for a controlled deorbit around 2030. But this isn't the end of our presence in low Earth orbit. Quite the opposite. It's a transition to a new era. An era where commercial space stations, built and operated by private companies, will take the reins, opening up even greater opportunities for research, exploration, and perhaps even space tourism. We're on the cusp of a paradigm shift in space exploration. Where government agencies like NASA once held a monopoly, private companies are now emerging as major players. This commercialization of space is driving innovation at an unprecedented rate. Companies like SpaceX, Blue Origin, and Axiom Space are developing their own spacecraft and space stations, with ambitions to build a thriving economy in low Earth orbit. Imagine a future where private citizens, not just astronauts, can experience the wonders of space travel. This transition to a commercially driven LEO economy will free up NASA to focus on even more ambitious goals, like returning to the Moon and venturing further into the cosmos. The International Space Station has served us well, but the future of low Earth orbit is ripe with possibilities. It's a future where scientific discovery, technological advancement, and the spirit of exploration converge to push the boundaries of human ingenuity. And I, for one, can't wait to see what we accomplish. We often think of NASA's missions as outward-facing, venturing into the cosmos to unravel the mysteries of the universe. But some of their most crucial work hits closer to home, literally. I'm talking about Earth science, the study of our own planet and the complex systems that govern its climate. NASA has a fleet of Earth-observing satellites that constantly monitor our planet's vital signs, from the temperature of the oceans to the concentration of greenhouse gases in the atmosphere. These satellites provide invaluable data that help us understand how our climate is changing and what we can do to mitigate the effects of climate change. One such mission is the upcoming Surface Water and Ocean Topography SWOT mission, a joint effort between NASA and the French space agency CNES. Launching in 2022, SWOT will give us the first ever global survey of Earth's surface water, allowing us to track changes in rivers, lakes, and reservoirs with unprecedented accuracy. This data will be crucial for managing water resources, predicting floods and droughts, and understanding how climate change is impacting the water cycle. It's a remarkable feat of engineering and a testament to the power of international collaboration in addressing global challenges. Earth's climate is a complex and interconnected system, and understanding it requires studying a multitude of factors. One area of ongoing research focuses on aerosols, tiny particles suspended in the atmosphere, and clouds, those fluffy formations we often take for granted. Aerosols, both natural and human-made, play a significant role in climate change by influencing how much sunlight reaches the Earth's surface and how clouds form. Clouds, in turn, are critical for regulating Earth's temperature, reflecting sunlight back into space and trapping heat. However, the interactions between aerosols, clouds, and the climate are incredibly complex and not fully understood. To address this, NASA is developing new missions to study these atmospheric components in greater detail. By unraveling the mysteries of aerosols and clouds, we can improve our climate models, make more accurate predictions about future climate change, and develop effective strategies to mitigate its impact. It's another example of how NASA's Earth science research is vital for protecting our planet for future generations. Space exploration has always been at the forefront of technological innovation, pushing the boundaries of what's possible. And in recent years, robotics has emerged as a game changer, revolutionizing how we explore the cosmos. From rovers traversing the Martian surface to robotic arms manipulating delicate instruments on the International Space Station, robots are becoming indispensable partners in our quest to understand the universe. They can operate in extreme environments, withstand harsh radiation, and perform tasks that would be too dangerous or impossible for humans. NASA is heavily invested in developing cutting-edge robotics technology, and for good reason. Robots offer a number of advantages over human explorers. They don't require life support systems, they can operate for extended periods without rest, and they can be sent on one-way missions to distant destinations. This allows us to explore more of the cosmos for a fraction of the cost and risk associated with human missions. It's not about replacing human exploration, but rather expanding our reach and capabilities in the universe. As we venture farther into the cosmos, we encounter a fundamental challenge: power. Solar panels, while effective in the inner solar system, become less efficient as we travel farther from the sun. Chemical rockets, while powerful, are limited by the amount of fuel they can carry. To overcome these limitations, NASA is investing in next-generation power and propulsion systems, with nuclear technology taking center stage. Nuclear fission reactors, which generate energy by splitting atoms, offer a compact and long-lasting power source for spacecraft and surface habitats. Nuclear thermal propulsion, which uses a reactor to heat a propellant and generate thrust, could significantly reduce travel times to Mars and beyond. Imagine traveling to Mars in a matter of months instead of years. These advancements in nuclear technology hold the key to unlocking new frontiers in space exploration, allowing us to reach destinations that were once considered out of reach. It's a testament to human ingenuity and our relentless pursuit of knowledge and exploration. Space, as we know, is unbelievably vast, and while it seems mostly empty, there's a surprising amount of stuff zipping around out there. Some of it, like asteroids and comets, can pose a real threat to life on Earth. Remember that time 66 million years ago when an asteroid wiped out the dinosaurs? Yeah, we don't want a repeat performance. That's where planetary defense comes in, a global effort to find, track, and potentially deflect these cosmic projectiles. And speaking of deflecting, we've actually done it. NASA's DART mission, short for Double Asteroid Redirection Test, successfully slammed a spacecraft into a small asteroid, changing its orbit. It was a test run, a proof of concept, and it worked. This was a huge step for humankind. For the first time, we demonstrated the ability to alter the trajectory of a celestial body. It's like cosmic billiards, but with the fate of civilization at stake. Of course, DART was just the beginning. To effectively protect our planet, we need to know what's out there. And that's where the NEO Surveyor mission comes in. NEO stands for Near Earth Object, and this space telescope will be our dedicated scout, searching for potentially hazardous asteroids and comets lurking in the darkness. Early detection is key, folks. The more time we have, the better our chances of mounting a successful defense. But finding these objects is only half the battle. We also need to understand their composition, their structure, and their potential to cause damage. This means more research, more observations, and maybe even sending probes to study these celestial wanderers up close. Because when it comes to planetary defense, knowledge is power. And in the vastness of space, a little knowledge can go a long way in ensuring humanity's survival. We've landed on the Moon, sent rovers to Mars, but our solar system is full of even more tantalizing destinations. Take Jupiter's moon Europa, for example. Europa is covered in an icy shell, and beneath that ice, scientists believe there's a vast salty ocean, an ocean that might be even bigger than all the oceans on Earth combined. And where there's water, as we know, there could be life. To unlock the secrets of this icy world, NASA is sending the Europa Clipper. This spacecraft will orbit Jupiter and make multiple close flybys of Europa, using its suite of instruments to study the moon's ice shell, its ocean, and its potential for habitability. Imagine that, an alien ocean, potentially teeming with life, right here in our own cosmic backyard. The Europa Clipper mission is our chance to peek beneath the ice and see what wonders await. But Europa isn't the only ocean moon out there. Saturn's moon Titan is even larger and boasts its own unique features, like lakes and rivers of liquid methane. Yes, you heard that right, methane. To explore this bizarre and fascinating world, NASA is sending the Dragonfly mission. Dragonfly is a drone-like spacecraft that will fly through Titan's thick atmosphere, landing in different locations to study its surface and search for signs of life. And let's not forget about the ice giants, Uranus and Neptune. These enigmatic planets are still shrouded in mystery, but future missions could shed light on their strange atmospheres, their tilted magnetic fields, and their intriguing systems of rings and moons. The outer solar system is a realm of icy giants, ocean moons, and endless possibilities. It's a reminder that our cosmic journey is just beginning, and there's so much more left to explore. For decades, space exploration was almost exclusively the domain of government agencies like NASA. But now, private companies like SpaceX, Blue Origin, and Rocket Lab are driving down costs and accelerating innovation. NASA is embracing this new era, forging public-private partnerships. This allows NASA to focus on scientific discovery and exploring the cosmos, while fostering a competitive commercial space industry, expanding humanity's access to space for research, education, and tourism. We're seeing the birth of a new spacefaring age, with private companies shaping our future among the stars. Now, some folks might ask, Neil, what is NASA getting out of all this? Well, let me tell you, these partnerships are yielding tangible benefits. Take the Commercial Lunar Payload Services Program, or CLPS, for example. It's like NASA's way of saying to private companies, hey, you've got the rockets, we've got the science experiments, let's deliver some groundbreaking research to the lunar surface, together. Through CLPS, NASA can leverage commercially developed lunar landers to send scientific instruments and technology demonstrations to the moon. This not only saves taxpayer dollars, but also accelerates our lunar exploration efforts. It's a win-win situation, fostering competition and innovation within the private sector while advancing our understanding of our celestial neighbor. But it doesn't stop there. We're seeing a surge in private astronaut missions, with companies like Axiom Space sending crews to the International Space Station. These missions not only provide valuable data and experience, but also pave the way for future commercial space stations, further expanding humanity's footprint in low Earth orbit. And who knows what the future holds? Maybe one day, instead of booking a flight to Paris or Tokyo, we'll be booking suborbital jaunts or lunar vacations. The possibilities are as boundless as the cosmos itself, and that, my friends, is incredibly exciting. Let's talk about the James Webb Space Telescope, or JWST for short. This, my friends, is not just a telescope, it's a time machine, a cosmic observatory that's peering billions of years into the past, revealing the universe's first galaxies and unlocking secrets of the early cosmos. Imagine JWST is so powerful it can detect the faintest infrared light from the most distant objects in the universe. It's like trying to spot a firefly next to a spotlight from across the galaxy. This incredible sensitivity allows us to study the formation of stars and galaxies, analyze the atmospheres of exoplanets, and search for signs of life beyond our solar system. And the images, oh, the images. The JWST has been sending back breathtaking views of the cosmos, nebulae painted across the sky like cosmic masterpieces, star clusters sparkling like celestial diamonds. These images don't just inspire awe and wonder, they provide invaluable data that's revolutionizing our understanding of the universe. The JWST is a testament to human ingenuity and our insatiable curiosity about the cosmos. It's a reminder that we are part of something far grander than ourselves, a universe teeming with wonder and mystery, waiting to be explored. But the cosmic journey doesn't end with JWST. NASA is developing the Nancy Grace Roman Space Telescope, set to launch in the mid-20s. This wide-field infrared telescope will unravel the mysteries of dark energy, study exoplanets in detail, and search for clues about the early universe. Proposed missions like LUVOIR and HABEX will push the boundaries of astronomy, allowing us to study the universe in new wavelengths and search for signs of life on Earth-like planets. Each new telescope is a giant leap forward, giving us clearer views of the cosmos. The future of astronomy is bright, filled with limitless possibilities. From returning to the moon and venturing to Mars, to studying our own planet and unraveling the mysteries of the cosmos, NASA's vision for the future is a blend of scientific exploration, international collaboration, and technological innovation. We've seen how NASA is embracing the private sector, fostering a new era of space exploration that's more accessible and dynamic than ever before. We've marveled at the stunning images from the James Webb Space Telescope, peering billions of years into the past and revolutionizing our understanding of the universe. And we've glimpsed the exciting possibilities of future missions, pushing the boundaries of human ingenuity and venturing further into the cosmic unknown. Stay tuned as we continue to explore the final frontier and expand humanity's presence in space. Don't forget to like, subscribe, and hit the bell icon for more updates on space exploration.